Section 2, Principle of Power of Equipment 555, the domino. It's a machine that converts mechanical energy into electrical energy or electrical energy into the mechanical energy when the output of the electrical energy is called with the output of the electrical energy is called the generator. When the output of the mechanical is called the motor. The generator and motor have the same but basic construction. Either both may be called a domino. Dominoes are reversible, capable of operation as either generator or a motor. But the practice of their many minor differences is design adjustment efficient performance. They are therefore designated according to the service of their performing. Dominoes have the following essential parts: magnet, field, armature, winding, commutator, collecting rings, except for the certain induction motors, mechanical parts that support the core bearings. Relationship previously described between the field and currents and motion. Current creates a electric motive force necessary to convert the mechanical and electrical energy into no difference whether the relatively modest motion is obtained. Stationary fields or moving fields, however, the locomotive applications of the fields are stationary, consistent with the magnetic pole faces bolted to the frame. Coils wound around the field poles are called field coils. The amount of the current in these coils determines the strength of the magnetic field. The magnetic field and the flux through the poles is called field excitation. The stationary poles of the frame are called the stator. The rotating coils are called armature and rotor and carrying load. The rotating coils are called armature or rotor carrying load current. B. The relations exist between the direction of the field, the direction of the motion, the direction of current should be remembered. Any one of these can be determined in the direction other than this. 2 is known. The determining method for the generators and is Fleming's right hand rule, motors of the Fleming's left hand rule. In each case, the forefinger and the middle finger are held in the right angles in each other. The thumb points in the direction of the motion, and the forefinger in the direction of the field. The middle finger points in the direction of the flow of the current. When the force causes the conductor to move through the field, and the current with the flows that cause an induced EMF and voltage and machine is a generator which impresses the voltage setups which causes the conductor to move the mechanical work to the machine is called the motor. The 56th, the basic generator. Since electric motive force EMF is related to the change of the field of motion, and it logically follows the amount of the EMF is related to the amount of change in the field of motion, and the value of the EMF depends on rapidity of the changes, which is generally termed the rate at which the lines of magnetic force are cut. The following 3 factors have the greatest effect on the EMF generator. 1. The change in speed or rotation or revolutions per minute of the armature, which causes the corresponding change in the EMF. Other things remaining the unchanged. Changes in flux density will cause corresponding change of the EMF. Otherwise, remaining unchanged, the flux density is changed by changing the current flowing of the given the field of the coil, changing the number of the turns of the wire in the field coil as. Here is the Fleming law with the 3 fingers, the thumb, the index, and the middle finger shows the motion of the field and the current out. The second, changing the flux density with the corresponding change in the EMF. The other remaining unchanged flux density is changed by changing the current of the flow in a given coil, changing the number of the turns of wires in the field coil. When a manufacturer builds a new design. 3. Changing the size of the field, the size of the turns of rotating coil. The new design will change the area of the flux path. While the EMF of the machine will vary from the manner outlined in the above, the EMF of the single armature rule will vary, while the speed, rotational flux density remaining the constant. Figure 40. He shows the position of the coil and makes the half-turn. Discussion follows the concerned length wire, the sweeps, the polar faces which extend perpendicular into the drawing the wire along the which EMF induces the figure 38 at the position shown at the 0 degrees in figure 40, and no flux in being out because the coil moves in a tangent, with the flux tangent being along the instead of across the flux at 20 degree one line being cut at 40 degree. 4 more lines have been out at the same period of time. Since it takes a table a long turn 2 turn 20% at the portion of the circular path when speed of the rotation remains a constant. At 60 degrees 6 or more lines have been out. At 100 degrees 7 or more lines have been out, and the EMF varies from the number of the lines which have been out been cut, been out of the 0 degrees from maximum 9 degrees. The values are out can be plotted in the curve in which the circular path of one revolution represented a straight line EMF at any of the point, along with the represented with the distance away from the line of 1, figure 41 at 180 degrees. EMF is 0. The same reason is given for the 0. A curve is the same pattern is developed between 180 and 360 degrees. The 360 degrees takes in 20, 40, and 60 electrons motive force to speed. The Emax is the AC sim wave and then commutated sine wave. Number 2, which brings the coil back to the 0 position. However, the EMF, the opposite direction of the Fleming rule, the curve is drawn below the line. The curve follows the mathematical waveform for the mathematics does not affect the present discussion. When the alternating describing the impressive complete circuit of the flow, the circuit varies from the same the manner that some device constitutes a similar alternator generator and the AC power supplied in a manner of one of the principal classification of the power system. Any AC machine ends up rotating the coils connected with the continuous metal rings and called the slip rings, which are mounted on the axis of the armature shaft and then insulated to each other. Metal and carbon blocks called brushes ride in the ring to make the contact the external circuit. The number of the complete waves and cycles generated per second is called the frequency, depending on the speed and design of the generator. Standard commercial power frequency is 60 cycles. Basic communicator. There are many uses for power system in which the current does not alternate, with the current always in the same direction. The term direct current, the generator supplies a direct current and system called the DC generator. Since the current of the armature is always alternating AC, some of the means that must be provided. To change the direction of flow before the enters the outside circuit, this can be done using the split ring instead of the 2 slip rings. Such device is called the commutator, essential for the external connections by changing the proper time. The commutator makes their force reverse the connection on the coil, respects the external circuits at the instant of the EMF reserved in a coil, which is done alternating current. The figure and shown in 1 and figure 41 becomes the pulsating direction of the shown in figure 2 and 41, and then the end of the connection to coils of the external circuit and called the communicator segment. This shows the AC sim wave at the Emax and the negative Emax, while the communicated sine wave has a travel above the 0 degrees possibilities with a 58. Direct current generator. The direct current generator supply described in paragraph 57 is not practicable for commercial use, but voltage reaches 0 twice in each revolution of the generator. The power output would be small. Practical generator or motor. This shows the coil outside the load of the brushes and the collector rings, which actually act as the communicator, which changes the direction of the flow, the direction of the rotation, and the back connection of the EMF coil and side. Must therefore have how many coils each of the coils connected in the pair of communicator segments. The generator is built in enlarging the principle of the figure in 3 coils, developing 3 separate sets of designated E, A, B, and C. Figure the dotted line represents an unused signs of the brushes as shown in the figure 43 are not using one pair of the communicator engine. The communicator segments at the time. The solid lines represent the time and the degrees at which the brush and the idles of the coil A, B, and C successfully the contacts made with the greatest EMF has been generated by the coils of the volt, and the line of the voltage has value represented in the solid line. The ripple smoothed out the constant direction current of the more coils as added. However, the dotted lines show that there is a large portion of inactive coils in an armature which shown that these diagram is called by an open circuit winding. If the coils are connected to each of the form the closed the circuit, the EMF represents a dotted line in figure 44 added to the line resultant EMF due to the ripple shown in 8 in figure 44, in which the total EMF sum of the individual EMFs are in constant generation diagrams in 2 poles. So I guess that shows the split lines and the regular, the full lines. This is a commutator with a brush, and the brushes and the axis rotation between the exciters and the generator, the direct rotation, axis rotation. It shows this is showing it very like different brushes, like for 6 different kinds, fielding the currents off the generator. And furthermore, improvements in construction operations possible or dynamo. Building machines with 4, 6, or more poles. Basic theory that unchanges the success of the machine. There are many types of circuits by which coils are connected by the closed windings. 59 typical direct current generators. Generators are classified in three general types depending on whether the fields are connected by the series shunts or combination of two. The series wounded generator has a field winding in the series with the armature, and the shunt wounding generator fields in the parallel with the armature. The generator has both series field and shunt and is called the compound wound generator. A shunt field, the circuit must have the comparative high resistance in order to not make it the greater the portion of the total armature current. A drop voltage is loading and increasing this characteristic of a shunt wound generator. This is found of the compound wound generator having a series of field boosted and added to the field of the strength of the low current, and hence the series field current increases. A separate excited generator has many important applications regulating if it would be difficult to regulate a field strength in the generator output, changing the currents of the self-excited windings of the locomotive is very definite in the category description. Special application is given later in paragraph 70 and 71. Construction of direct and current generators, the interpoles. Paragraph 57 indicates the first glance of the voltage induced on a rotating coil, whether the reverse itself halfway between the fields, actually the flux distorted in the air gap, the zero EMF, the coil occurs slightly off center. The generator occurs in the advanced theoretical neutral position in the motor. It occurs behind the neutral point, and the brushes are not set in at a point of the zero EMF. The current is broken as the communicator turns, and there is a spark. In the brushes. Brushes are mounted so that they can be shifted and leading and lagging the position to avoid sparking. However, the self-induced EMF into the coils, the neutral point of the brushes are always in the fringes of the flex between the poles, and the manner of the difficulty to obtain satisfactory communication. The most satisfactory solution has been to introduce a separate flux which produces desired flux density in the neutral zone. This is done by the small narrow poles of the inner poles, communication poles, and located between the main poles. The lamination field cores and armatures are built up layers and sheaths to reduce the strap of the currents called eddy currents. Science iron is most of the good of the conductors of the electrical as copper, and electrical current tends to flow almost as readily as iron as in the copper, but the lack of an outside circuit, therefore the circuit of the circuit within the cores of the generator excessively heated with representing the lost power. The eddy currents are much more less laminated core than they would be in solid core. Armature laminations can be keyed directly to the armature shaft that they have punched, provided the passageway through the air can circulator carry away the heat. Self-ventilation, the generator is provided the built-in blower on the shaft. The forces are air through the machine that operates the six carries away from the heat of which is accumulated with serious limits of capacity of the generator. D. The winding. Generator brushes more have than one set of the brushes are set for their poles. Poles occupy only a portion of the circle of the same armature. Types of connection of each of them called the end windings. Wave windings. The main elements designed to determine the choice of the choice of the windings, but in the general coils and lamp and winding overlapping each other connected in the parallel, while the wave winding proceeds in series armed armature. The coil voltage is lower than the line voltage is a wide wave winding, but the same current flows through all coils. Voltages as higher. But here you see the 45 90 degree angle, the 40 45, the 30 60 60 60 60 30 complete circulated waveforms of A, B, and C, and of C, A through D. Let me view this on the side. Okay, here's the commutator with the switch open. It runs it's from the switch to the load to the communicator, back into two armature windings. The same thing below for the second, and the communicator is changed from a relay switch to the load current or load series and current series wound generator. It's hard to tell. Well, anyways, you have the communicator switched in the load fields, running in parallel circuits with a relay. Pretty much, the only break in the relay is this. Is the switch with field and load. This one runs a double. Load 3 is a compound wound generator. Load 2 is a shunt wound generator. Series 1 is a wounded shunt generator. Basically taking the field and load on the same one as a wounded, having two different lines on the relay. For the communicator is two double shunted two shunt wounded generator, and three compound wound generator. It shows the series field load and shield field in the current without a relay. Or on the side here, you can see it wrapped around with a switch in the loads. Okay, 60 current is lower than lamp wound coils than the wave wound coils. 61 direct current motors. Since the motor is similar to the generator except for the refinements, design, and detailed description of the generator will not be repeated. However, it is well understood that certain types of are usually center work and general voltage precedes and speed of the current produces the torque. The shunt motor is used where the substantial constant and speed of the desired, therefore the suitable driving fuel supply in the fan motors and the similar auxiliary locomotive direct current power lines. The speed of the shunt motors verified the slight of the changes in load having definite load and speed with a greater contrast. The action of the motor series of the motor which will speed up faster and will have serious damage. Series motors have serious operating advantage. Traction services fortunate they are always connected to the load unless the wheels are derailed will necessitate a special caution given in the later the operating instructions. The locomotive requiring high torque for starting acceleration when speed increases less torque is needed since the voltage is significantly factored with respect to the good low voltage is sufficient when starting. Additional voltage needed with speed increase. The power system constantly adjusts with the initial itself gradually to verifying the condition of the load of the equation of the paragraph 50 they express in the product of the voltage current. Diesel engine was previously described having a constant or outpost since the product of the low voltage high current of the starting of the engine series motors approximately product of the high voltage low current of when running the power of the output of the driving wheels approximately the constant output of the diesel engine design related to the loaded control of the device is simplified. The field shunting of the traction motor is generally provided with the connection resistance of the parallel with the field. When the field is weakened, the shut in the field, the current of the immediately increase the motor of the current because of the back EMF of the torque and the power. This is increased. The torque accelerates the locomotive at the higher speed until the new balanced condition is reached. The field shunting is taken place when the current reaches a low value. The product of the voltage times the current number of the equal diesel engine power output. And that new set of the conditions makes it possible to load the diesel engine capacity throughout a broader operation range. 62 overloads. An electrical service is previously defined as the conductor through which the current flows. It also has been shown that the conductor that offered the resistance for the current flow. The combination of the current and the resistance have been shown to produce the heat and also voltage drop. The conductors and the wires are kept to keep the cost of the space with requirements low, and in the power line, a piece of equipment. These conductors are designed for specific services because of the heavy load of the conditions. Even often occurred where wires are chosen which can carry some of the load of above normal. Excessive load will be damaged in institution equipment with any of the current above the practical limit is called overload. Overload protection is provided with the devices which break the circuit before the equipment is damaged. A fuse of the metal alloy with low melting point which connected directly to the circuit of the carrying the current of excessive current causes the metal to metal output open the circuit. The burnout fuse must be replaced to establish the circuit again. The fusible element is mounted in the casing the confining of that are which the producer of the metal circuit breaker is a switch with open the tripped magnet coil with the current of the circuit reaches the predetermined limit of which the coil exerts enough force to open the breaker. The breakers are permanently fixtures in the circuit and may be closed again when the fault is corrected. 63. Locomotive circuits. The three basic types of circuits are series circuits, parallel circuits, and series parallel circuits. The series circuits are the same current phases that have each device connection is completing in its past source of supply, and the total resistance of the circuit is equal to the sum of the resistance of all the portions of the circuit. In a parallel circuit, the current from the source is divided through the two or more parallel paths. The total current of the sum or equals the sum of the current of the parallel paths. The resistance of the parallel circuit is always lower than the resistance of the individual parallel path. The series of parallel circuits is a combination series of parallel circuits. The standing of the Christmas tree lamps, in which the lamps go out when the lamp burns out, opens the circuit. It is a familiar example of the series of the circuit. That each lamp can be standing only on the portion of the voltage from a house circuit. The more expensive Christmas lights, in which other lamps continue to burn when one light lamp burns out, is parallel lamp circuit. Each lamp operates on the house voltage. If the motors are connected in the same manner as the lamps, the same circuit of the characteristic applies. A different operating characteristic of the motors, different voltages are chief reasons for the relatively great number of the methods for connecting traction motors. The power of the main generator locomotive is carried by the electrical cables. Traction motors, which are generated with the driven axles, the main power of the circuit is in the path taken of the current that flows in the generator through the cables, motors back, and the generator. The circuit is open and the closed, and the heavy-duty power switches, electrical drive, is in effect the variable transmission, infinite number of the gear ratios of the throttle. The remains of the first notch of the current of the amperage decrease rapidly after the initial surge of the power because of the motors, which are also increasing speeds, developing greater counter voltage or back EMF. The power delivered from the locomotive decreases. The engine generator can be delivered more if their speed increases, moving the throttle to the higher position, which increases the fuel supply described in paragraph 35 through 37. This increases the generator voltage amperage of the locomotive traction effort, which throttle remains in the position current. Again, the decrease of the varied position of the throttle represents a continual adjustment of the varied voltage current traction effort to get them in engine power within the capability of delivering. The principal limitation of electrical overload, the tendency of the driving wheels to slip and spin as the throttle is advanced at the far possible engine speed of the generator voltage as the maximum. However, the locomotive speed continues to increase the current to decrease before the power output of the product amp time voltage decreases. Under these conditions, the power which the diesel engine can deliver is no longer being used. Fuel power output again using the current, but it can be increased. This can be done by changing the traction motor connection, starting the train following the requirements encountered with the high pulling power to traction effort. High current amperage necessary because the torque of the motor are proportional to the amperage. Low voltage sufficient to produce high current with the locomotive standing in the traveling very slow. The high diesel engine and the generator are turning low speed because of the throttle is at the low notch. The contactors are magnetically operated switches from the opening and the closing of the circuits energized by the low voltage from the battery circuit. The several types of the installed locomotives are suited with the particular application. However, the operation and maintenance with all the types is essential in the same low voltage control circuit energies. And this shows a series of circuits with the generator on side, with the motor fields and the motor armatures, parallel circuits instead of series of circuits run by a generator in different motor armatures running on each different motor fields. This shows a series of parallel circuits, the parallel circuits with the two different parallel circuits here. Splitting up the voltage from 1 to 3 and 2 to 4 on the armatures and the motor fields of the basic electrical circuits. Electrical motors bring the movable contact with the stationary contact of the main circuit. The spring moves the opposite direction with the electrical magnetic energized. Low voltage can be fed through the varied interlockable and automatic controls, hand-operated switches. In consequence, flexibility installation makes it necessary to consult the proper wiring diagram to determine the exact operation circumstance for any of the conductor, blowing out the coils adjacent to the contacting, the minimizing or arcing of the arc shields, protecting adjacent parts of the burning, and the arc interlocks with the arm auxiliary switches. Mounted on the control are controlled by another switch of the contractor valve with a similar equipment. The contracting switches operated the cam linkage, which opens and closes the contact. Definite relationship with the position of the main piece of the equipment. The purpose is the control the making the breaking of the related circuits only when the proper condition exists. The interlocks are closed with and the closed when the main switch is closed. The outer the interlocks closed when the main switch is open. The several interlocks are mounted on the piece of equipment and then required in the in and out combination. Magnet. Very consistent. The magnet cord acting upon the air valve of the coil is low voltage control circuit connected to the interlocking automatic controls. Manual controls the same manner of the coil. The contact usually returns to its de-energized position. Spring action the valve of the coil are also used in the application of the shutter control. The compressor synchronization standing as well as reverse power switches is built into the power of the equipment. Half the relay is a small magnet type of the electric, which consists of a coil, several small contacts, the devices, chains, connections, and one part of the typical circuit of the responsive chains taking the elsewhere current. The coil may either be the high voltage or low voltage circuit of the locomotive. Railway operators may operate in such manner the contactors, but are required to carry the heavy current Generally much smaller, they are more adjusted to the open and closed various voltage, responding to the various operational conditions. The contacts of the relay, the close to the circuit to the solenoid, the contact of the magnet valve, the controlled with the relay. More the one contactor and the magnet valve, and the one can be controlled by the relay building of the relay. And several set of the contacts. 64 symbols. When an electrician or a designer of the decides to connect the electrical equipment in a certain way, he must have the information sum of the form that conveys the information to anyone who wants to build it and needs to prepare the sum of the future picture of parts and circuit, sometimes using the training for the purpose of the elementary work. For any of the large circuits with a difficult draw, read the equipment is represented in similar stretches. Specific means the circuit can be easily drawn and read. These sketches are symbols, and symbols must be frequently in locomotive circuits as shown in the figure 47. There are some more advantages to using them. The universal standards are adopted to convey the same information. Therefore, the revision, deviation from the time to time, familiarity with their normal usage of clarifying many of the problems, symbol represent the basic figure apparatus instead of separate symbols for each one of the equipment. For example, the coil, the ground relay, the wheel slippage relay, a field shunt relay, or other railway, always represented by the same symbol operating the coil or the same symbol contacts. They always perform the same basic function, and operating coils are always magnetized. Moving the plunger when opening and closing the contacts on the electrical magnetic equipment opens and closes the valve. In the symbols are the supplemented letters which offer abbreviation equipment for such as GR for the ground relay, WS for wheel slippage relay. The letters tend to standardization with the given field. The legend is readily supplied, but appears on each of the drawing symbols. The various parts of the equipment are often separated with wyogram. For example, the ground relay is used to protect the high voltage power circuit, and the operating the coils is the circuit, and the response is closed relay consists of light bells and idling controls, all which are low voltage circuits. I'm going to switch out of this to 75 so you can see this. General motor armature shows a circle with two parallel connections to it. One single pole switch has a cross, and cross is like a door hinge. The coil of generator field motor field relay contactor is given a zigzag line. A double pole switch is given two cross single pole switches, also called the knife switch. The drum type switch is shown as a kind of a key, like a G, like a piece of key. Double pole switch shows the snap switch shows two throw switches with a snap switch. Interlocking normal operation shows it's basically a block built before the two relays. Interlocking normally closed. One on the inside instead of the outside. Push button is just like kind of like a block with a little T on it. A storage battery is a plus with many small dashes and longer dashes going horizontal across the vertical, or going vertical across the horizontal line with a minus and a plus, marking the storage battery. Fixed resistor shows as a block type wire, or as a block type, or a block zigzag, or a block in the fixed is a resistor. The fuse shows as a signal indicating 5 amperes by a 5A. A wire resistor shows a fixed resistor over two parallel currents. A pair in the line. Amateur shunt was shown by basically a box with an AO armature with a shift. The negative side of the battery shows is a point of zero drawn into an output, like a dead end zero slash. A cilium reflector is given a pothead symbol without the circle. For other wiring capabilities, wire grounded also get to the locomotive is given as a down triangle pyramid of lines. Light receptacle is given 2 dashes inside of a circle. Wires connected either as in parallel or perpendicular with full dots. Battery charging is a double-shotted circle charging receptacle. Capacitors are known as fork drawers. Lights is drawn with a zero. A series of fields is drawn with a humped current field. The circuit breaker is then given a fixed resistor with a switch and a 15 amp, and given the ampere downage as a switch. For the reverse is given um, two sets of line and a box of the current relay. Kind of think of the communicator like different setup and just different tapping of the wire. A rheostat, and I'm gonna come back in here and read the rest of this. Maybe 125. Schematic drawings, wire drawing is a sketch of the sketch with the connection are shown different from the actual wiring. The objective of explaining the operation more clearly. The circuit is generally drawn in a simple diagram with little turning in the crossing or backtracking the lines as possible. The actual wiring diagram corresponds nearly to the actual location apparatus continuity of the wire. The simple circuit of this would be first pictuated as someone in the mind is shown in the figure. In one figure 48 has listed has little use except for elementary training programs. Schematic circuits show that conveys the principal function, operational purpose. The purpose of the circuit shown in 2 and figure 48. An actual wiregram is prepared with the schematic drawing after the schematic has been studied to ensure the satisfactory operation of the circuit. Typical additional circuit is generated with the charge of the battery, then the fuse of the circuit, the breaker to protect the circuit. Then, in case of the locomotive interlocking, the guarantee that the circuit is open under the certain operations that involve with the nature of any form of the diagram. The schematic diagram is quite apparent. The additional for the only 3 symbols, the existing line of the schematic drawing is clearly conveyed the information. The actual wiring diagram of the locomotive symbol of the black wire schematic drawing must be shown in the running of the auxiliary generator in the engine room, and the battery beneath the frame of the intermediate wiring for the battery, animated for the control panel, and the battery charging resistor electrical cabinet that becomes involved with the diagram, broken into several parts of the terminating and terminal boards, which are strategically located in the key points of the locomotive. Group the wires to terminal boards with non-direct connection in an apparatus called the wiring harness. In tracing the circuit, and will assume the starting point of the source of the power designated with the post to the side of the circuit of the direct current of the systems which are accessibly for the diesel electrical locomotive power of the control apparatus. Main power circuit is then one of the easiest tracks. Recalling the current flows of the positive and negative lines to any motor circuit of the diagram showing the current of the pass through the power switch of the motor armature instead of the contacts on the reverse motor fields and on the other set of contacts of the reverser to reach the negative side of the circuit leading from the brake of the generator, tracing the leading of the back of the generator, tracing the control circuit of the positive side of the auxiliary generator into the battery source of the battery power, establishes starting point of the engine, starting the circuits of the all locomotive fundamentally in the source of the power. Therefore, the main battery search for starting the contact with the generator, the crank of the engine. Therefore, the back the negative side of the battery. Likewise, in all throttle control circuits, is extended to the source of the battery through the control stand to the operation coil of the various power control equipment for the negative side of the control circuit. A review of the paragraph 64 will now show the purpose of separate symbols for operating coil contacts. The control circuits have been completely traced for the operating coils and such more power. The equipment is the reverser, power switchers, and the additional contacts with the coils operating that take place in the main power circuit is the first trace, and power checked up interlocking similar devices. Any other similar diagram of the study of the circuits must be supplemented and experience through training of specific circuits is necessary to fully understand the trace of the circuit and seldom necessary locomotive operation. Extensive done in the maintenance work on the fundamental and the replacement of the fuse and hosing of the circuit. One is a picture of the diagram from the battery to the ammeter of the resistor while following the both sides of the charge on a voltmeter. The schematic of the drawing will be shown as the voltmeter plus the negative side of the battery at E 12 volts and going through the ammeter on one side and then hitting a resistor and in the schematic and going back to the battery in the schematic of the circuit. This shows a more complicated one with the following the drops and transitions and pick up the different resistors and coils and DC field generators. This is the main power circuit. The A2s and breaker alternator setting and the cutting out of the emergency operation, the same detailed sequence testing for the maintenance repair work and indicating control devices, set up prevalently road trouble so that the crew attempt the remedies beyond the rule of the measure, whereas the shop must be as more thoroughly studied. The ground is connected by the resistor through the current by the switch into 108 through which it goes to the voltage and current coil transition relay through another resistor to another parallel circuit where it hits the fields of FFF and 3/4 columnar fields and divide fields acceptors. It's very hard detailed. Chapter 10, main power system.